Okay, so here is today's starter. You were given two buggy cars, and these are the mathematical models that describe how the position of those buggy cars change with time. Their starting positions, and this is how fast they're going and in what direction. Buggy car A is moving in a positive direction, buggy car B is moving in a negative direction. And so what we want to do is draw a graph with both of these equations on the graph, and from 0 to 20 seconds, and we're going to see when and where are they going to collide. When are they going to smash into each other? Or, in other words, when are the graphs going to intersect? Because that's what happens. So here is, and I've already done it, so I'm just going to, in the interest of time, I'm going to show what the graph looks like. So here is buggy car A. And what I did is I said, well, 11 meters is good enough for position because that's the farthest buggy car A goes in 10 seconds. It's going to go to 11 meters. And so, I'm sorry? Okay, so anyway, here's A right here. And it starts at 1 meter, and then it goes all the way up to 11 meters. And I just drew a straight line. When you're given the equation, you can just pick 2 points and then draw the line between them. And then I checked it, and it works. Okay, and then B, well, here's buggy car B. At 0 seconds, it starts at 10 meters. And then at 20 seconds, well, 20 times negative 0.3 is negative 6. Negative 6 plus 10 is 4 meters, so it'll end up being at 4 meters. So here's 4 meters. And then I just connected them. And look where they cross right here. And so here is where they intersect. So just by looking at my hand sketch, now this is just a hand sketch graph. If you have graph paper and you're using rulers and you're making it all beautiful, your answers will be right on. But, so I look down here, and I go down. It looks like about 11 seconds. So they will crash after 11 seconds. And then I come across here, and it goes, it looks like about 7 meters. So that's my answer based on the graph. I said about 11 seconds at a position of 7 meters, the buggy cars will crash into each other. Okay? But then I decided to do it using the mathematical models alone to get a more precise answer. And actually, by the way, if you draw a really beautiful graph, you will get precise, because if you look really carefully, if I use graph paper, it's a little over 11 seconds. And if I come across here, it's a little under 7 meters. And I think if you draw a nice big graph, you'll get that. So what I did, though, is I solved these two equations simultaneously. And you've done this in your math class. And by the way, you don't have to copy this part down. This is what I asked you to do right here. And this is good enough. But what you're going to be doing for the homework tonight, and what you're going to be doing on Friday for the buggy car quiz, is you're going to be doing this mathematically, as well as graphically if you want. You can do it graphically if you want, but you're going to want to do it mathematically to get a more precise answer. And here's what you do. And this is kind of a mess, so sorry. This is what I did last time. I started off with this. This is my equation for car A, and this is my equation for car B. Now, when they collide, they are at the same position, aren't they? You're out in the parking lot. You're trying to get to Taco Bell, as soon as possible after lunch starts. And then you found that you've collided with another senior in the parking lot because what happened was you tried to occupy the same position at the same time. Okay, that's bad. That's what's known as a collision. So, so you have the same position. So basically you could say that when they collide, their positions are the same. So here's what I did. I said x of A equals x of B. Does that make sense to everybody? The position A will equal position B when they collide. I think that makes a lot of sense. And so I said, well, but the position of A is described by this. So this is the position of car A. And it will be equal, this is the position of car B. So I set these equations equal to each other. And then, when I have this, my only variable is time. Look at, see, time? It's the only variable. So here's what I did. I added 0.3 meters per second times time to both sides. I subtracted 1 meter from both sides. And look what I get. When I get 0.5 plus 0.3, I get 0.8 meters per second times time equals, and then I add these up, you get 9 meters. Right? 10 plus -1 is 9 meters. Yes? Does everybody follow what I did? Okay. And then I solve for time by dividing 9 meters by 0.8 meters per second. By the way, look at the units here. Meters cancels the meters. You're left with 1 over seconds. You reciprocate and multiply, you get seconds. 11.25 seconds. Then what I do is I take this 11.25 seconds and I plug them into my equation for car A and for car B and see if I get the same answer. It's a way of checking my work. If I plug it into car A, I get 0.5 times meters per second times 11.25 seconds plus 1 meter. When you do the arithmetic, you get 6.625 meters. If I take that time and plug it into the equation for car B, lo and behold, I get the same answer. What does that mean?
And it's right.
That it's right. Yeah, I did it right. Yeah, good for me. I feel good about myself now. All right. Now, so my final position, or the position when the cars hit each other, or maybe they'll miss each other and just pass each other by, is 6.625 meters. Now you might want to round these off to the nearest tenth of a second. But let me tell you, look at the answer for the graph. Do you see that 11 is pretty close to 11.25? In fact, if you round off to 2 significant figures, this is good enough. If you look at this, look at the position. If you round this off to the nearest whole number, then this is pretty good. So the graph agrees with my math. Okay. And that's always a good thing. So now, this is what you're going to be doing when we do the buggy car quiz. I want you to solve the equations simultaneously, but I also want you to see that if you graph these equations, you will get the same answer. Yes?
So to get the x, you multiply 9 and 0.8?
Oh, I divided by both sides by 0.8 to solve for time.
No. After you got the time, you found x or something, you said?
Oh, yeah, up here. What I did is I took this time.
Oh, and then you put it in.
And I plugged it into my position equations to find the position where they collided. And I did it for both of the cars. And you can see that they both gave me the same answer. So that means at the same time, they are at the same place. Okay, any questions? Good questions. All right, that is all.